Hello everyone, welcome to lecture 36. So, today we will talk about the present and future scopes of remote sensing in natural hazard studies, right. So, to understand the present and future scopes, we need to understand the capabilities or advantages of the remote sensing as well as the limitations of remote sensing in natural hazard studies. To start with, these are the advantages of remote sensing in natural hazard studies. So, here the first one is the large area coverage, right. So, when we talk about this space based measurement, our area is comparatively large because the distance between the target and the sensor is huge. The second one is the non-destructive data collection. Here, when we try to collect the information using the electromagnetic energies, the samples are not getting disturbed and they remain in the natural settings, right. Then comes the high spatial, spectral and temporal images. So, here we mean the spatial resolution, spectral resolution and temporal resolution. With the advancement in the technology, these are increasing day by day, right, which has led to the more precise information extraction from the remote sensing images in terms of the parameter which are required for any natural hazard studies. Then comes the access to inaccessible areas. Particularly during the hazard or post hazard, it is very difficult to reach the area. Why? Because the area will have the non-accessibility and some of the areas are inaccessible by nature also. So, in such situation, remote sensing plays a very crucial role here to provide the information. And as I said, the real time or near real time data sets will be available, which is not possible by any other mean, right. Wide range of data across the wavelength is also available, because depending upon the target, depending upon the nature of the hazard, depending upon the area, depending upon the weather condition, you can choose whether optical remote sensing data sets are more useful or the microwave remote sensing data sets are more useful. So, you need to select wisely which particular wavelength region is more useful in your study. Systematic and repetitive data collection, that is another advantage. So, if you refer to any of the satellites, let us say we have the Landsat data series. So, these Landsat series, all the data sets acquired till dates are available in the archive. So, if you want to study what was the condition of a particular glacial lake in 1980 and what is the status now, you can use the same sensor data provided by different series and you can analyze the changes for the same wavelength, for the same area acquired by the same sensor, but with time how the particular area has evolved, that you will be able to analyze because the data format remain same. So, the hazard prone areas are difficult to access, particularly during or after disaster. This is what we discussed in the last slide. So, here it will provide the physical barrier because of the natural hazard. So, rough terrain, dense vegetation, collapsed infrastructure like roads, bridges or the hazard itself will restrict you to reach the area. Then the safety concern, it might be too dangerous for rescue teams, aid workers or even residents to enter or remain in these areas due to ongoing threats. Then comes the infrastructure. Remote areas might not have existing road or transportation network, making them naturally inaccessible. So, in such situation what happens? The area itself becomes inaccessible and we need to have some information so that we can start the disaster relief, right. So, the implications of inaccessibility can be understood here. The challenges of disaster response, increased vulnerability of population, difficulties in monitoring and preparedness and then prolonged recovery. So, if the area we do not have any information, it will take more time to respond and the recovery itself will take more time, right. So, the remote sensing provides access to an inaccessible areas in terms of information, right. Remote sensing data sets provide vital information during or the post disaster event, right, and these information can be interpreted and then subsequently the support can be provided. When we talk about the data collection, particularly in remote sensing, so here you can see in any other analysis you are disturbing the natural setting of the sample, right. So, here we are collecting the samples in gunny bags or the samples for this eye score that will be extracted. So, we are trying to change the natural setting, but if we want to have the in situ information, that is only possible when we are having the remote sensing sensors. So, the data collection through conventional techniques or through any other instruments require disturbing the natural form of the samples, right. However, remote sensing based measurement like space borne or airborne are non-destructive in nature. We are not changing the sample settings. So, when we talk about the advantages, so with advancement in the technology, we have high spatial, spectral and temporal resolution. This is an example where we have used the 1988 as our reference image, and with respect to 1988, how the river boundaries have changed in 1992, that you can see. Here with respect to 1988, 2002, then in 2014, how the river is changing its course, right, that can be understood. Similarly, when we are having the frequent measurements or acquisition of images for any glacial body, that can be used to measure the velocity, as well as we can also model this, and you can see how beautifully you can observe the changes, how it is flowing, in which direction it is flowing, which of the tributaries are giving more input to this. So, those things we can analyze, right. So, the consecutive measurements or observation at a specific time interval helps to study a phenomena. It can be any natural hazard. So, when we talk about the high spatial resolution, I hope you remember the spatial resolution is the size of the pixel which is representing the ground, right. So, one pixel might be representing 10 by 10 meter on the ground, or 30 by 30 meter, or 20 by 20 centimeter. So, this is called spatial resolution. So, here you can see one example. When you are having the coarse resolution, you can see a larger object, but subsequently when you having the improved spatial resolution, how the information is increasing for a particular target, and ultimately you can also identify a particular object or a particular phenomena and how it looks like on the ground, right. Similarly, high spectral resolution will provide you more information to derive the information or to identify or characterize the material when you are having high spectral resolution. So, here you can see this is basically low spectral resolution, right, and all these points are connected. But here when we talk about the hyperspectral remote sensing, we are having too many data points across the wavelength that helps us to identify which of the particular absorption feature is more evident here and which we can use as a characteristic nature of a particular material, and subsequently we identify the material characteristic, right. So, this is known as low spectral resolution, this is high spectral resolution. So, wide range of data sets are available through remote sensing sensors, particularly at higher altitude. The major problem what we face is the cloud coverage because of the bad weather. So, in such situation we use the microwave remote sensing data, because the optical remote sensing data sets will be basically hindered by our cloud coverage as well as the other parameters of the weather, right. So, optical remote sensing data sets is often difficult to use during disaster due to frequent cloud cover, particularly in high altitude regions. But in such situation, we have the option, we have microwave remote sensing data, which becomes very important source of information, particularly during a bad weather condition, right. So, real time or near real time data sets are available with remote sensing that helps us to identify what has happened during a particular catastrophic natural hazard, right. So, this is one example from South Lonak Lake. This is another example from the QuickBird satellite image of tsunami damage. It was from Sri Lanka, and here you can see this is the before tsunami, right, how the area looks like. Then we have few minutes before tsunami, how the waves are generated, you can see here. Then this is during tsunami, you can see how things are changing, right. So, this is from QuickBird satellite image. This is another example where we are utilizing the remote sensing data sets for flood studies. So, how a particular area is susceptible to flood, that we can study. So, this is the no flood image. This is another image for the flood, and then we can identify what are the areas which are flooded during a particular flood event, right. So, this is one of the example how satellite images or remote sensing images are used in natural disaster. So, the remote sensing currently plays a crucial role in all phases of natural hazard management, including preparedness, response and recovery. So, the present scope includes data collection in inaccessible areas that we have discussed in detail, hazard mapping and monitoring, then we have vulnerability assessment, then we have damage assessment, and we can also go for early warning system development using the remote sensing data input, and that will help us to save the life and property. So, when we talk about the data collection in inaccessible areas, so here we have satellite images, then we have UAVs nowadays are very popular. So, these are two different types of measurement in remote sensing that is being used. Then comes the hazard mapping and monitoring, vulnerability assessment, damage assessment. Here you can see the example of monitoring. So, here this South Lonak Lake, how it is changing with time. Then we have the example of glacial lake vulnerability analysis, where we can identify which of the lakes are more or highly vulnerable, which are safe, right. Here this is another example how a glacial lake is changing, how the retreating is behaving in this particular area. So, this kind of information you can extract using the remote sensing data set. Then this is another example of vulnerability assessment. So, which of the areas are highly susceptible to flood or low susceptible. So, this very low, low, medium, high and very high, these can be studied, right. This is another example of damage assessment where we have the example. So, this is the damage density. Here you can see the scale and the color, and the yellow boundary is for landslide, blue is for water and green is for vegetation. Now, you try to understand what information is available in this particular image, right. So, the damage density map per unit area of 50 meter, that is given here. Light color represents a lower probability of damage, dark color represents a higher probability of damage, refer to this particular legend, right. Green represents vegetation, blue represents water, the black line represents the fault, right. So, here you can see this particular black line. So, this kind of analysis can be done especially for the damage assessment. Then for the early warning system, I have covered this in detail in some of the lectures. When we talk about the early warning system, there should be monitoring and prediction, then communicating alerts and responding. These three are the key component of the early warning system. So, here it includes risk knowledge, monitoring and prediction, dissemination of the information, responses. If any one of them fail, that will disqualify this particular model for being the early warning system, right. So, this is very important. Now, we will try to understand the future scope of remote sensing in natural hazard. The future of remote sensing in natural hazard studies is characterized by enhanced capabilities, that is increased integration and more sophisticated analytical techniques, right. So, that way we will be able to go for more precise information. So, definitely we will have higher spatial, spectral and temporal resolution. Then we are talking about the integration of multi-sensor data, that is very important. As we have understood that some of the areas have limitations with the optical remote sensing data set, but we also have some other sensor like LiDAR that can be also used here, right. Then advanced analytics and artificial intelligence, then autonomous system and unmanned aerial vehicles that can be used, cloud computing and geospatial platform, then IoT can also be integrated here, and the development of new sensors with the new capabilities that is also expected in the future, right. The future of remote sensing in natural hazard studies will be characterized by a shift towards more autonomous, integrated and intelligent system, leading to more accurate prediction, faster response and ultimately better resilience to natural disaster. So, what is the purpose of this natural hazard studies? To save the life and property, right. So, as we are moving towards more advanced technology, more advanced analytical techniques, we will have better prediction, better model for a particular disaster, and then we will be able to save more lives and property. Multi-sensor data integration for natural hazard studies. So, here we were talking about the comprehensive and complementary information, right. So, when we have this, then we can have the optical remote sensing data set, microwave remote sensing data set, thermal sensors, LiDAR, these can be used together. Then we have improved accuracy and reliability. So, the validation and cross referencing will be easy and the ambiguities will be reduced, right. Then we have enhanced hazard detection and early warning. So, identification of precursory signals, validation and cross referencing, then reduced ambiguity. So, these will be part of this enhanced hazard detection, and then ultimately comprehensive impact assessment and post disaster response can be achieved. When we talk about the advanced analytics and artificial intelligence or the autonomous system and UAVs and then IoT based data integration. So, here that will help us to improve the accuracy of the prediction. Then autonomous system for early warning system. So, we do not have to do it again and again, and the system itself will be trained in such a way so that it will give you the warning. Real time and near real time data integration in the model, that will be possible because we are talking about the IoT, right. Then the cloud computing and geospatial platforms, which are very popular nowadays and it is very useful in hazard studies. So, one of the example is Google Earth Engine. So, real time data streaming from multiple satellite is possible. Automated alert system using scripts, easily scalable to any geographic area, it can be local, regional or global, right. So, when we talk about this cloud computing facility, we have satellite imagery, you can have your algorithm and then you can have your own application areas, right. So, particularly when we talk about the Google Earth Engine, it is a platform for scientific analysis and visualization of geospatial data set. Earth Engine hosts satellite imagery and stores it in a public data archive including historical Earth images. Earth Engine also provide APIs and other tools to enable the analysis of large data set. It offers tools for geospatial analysis, including interactive and batch processing model, because sometimes the data sets are very large. So, the batch processing facility is also there, as well as Python and JavaScript development environments are also available. User can visualize and export result to various format and platforms, and then further it can be analyzed. Earth Engine incorporates machine learning capabilities for tasks like regression, classification and image segmentation that integrates with Vertex, right, and for advanced modeling. So, remember this Google Earth Engine, as of now it is only for the non-profitable organization and academics. So, these are widely used these days. So, this is one of the example, this is a snapshot of code editor. So, this you can use and you can do your studies. I hope you have understood the present and future scopes of remote sensing dataset in hazard studies. I hope you will be able to use these in your research. Thank you very much.